Hello my dear students, this is Akash HD and welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the combination of the resistors like series combination, parallel combination, and after that we will solve some basic questions also. Okay, so let's start the video and let's learn this concept. So here you can see under the combination of the resistors, the first one we are going to see the series combination. As you know very well, in series combination, current through each resistor remains same. What is same? The current through each resistor is same, but potential gets distributed as shown in circuit diagram. Okay, so here you can see here I have taken here the three resistors. This is R1, this is R2, this is R3. These three resistors are connected in series. How can we tell? Because let's take, if current I is coming from the battery, then what will happen? In this resistor, this one, in all the three resistors, how much current will flow? The current will be I. Okay, and here again it will come back. This is the positive terminal, this is the negative terminal. Okay, and let's take what is there. The potential drop across the resistors are V1, here V2, and here V3. Why I am taking V1, V2, V3? Because the values are different. R1, R2, R3 values are different. That's why we are taking different. Okay, and here let's take, this is the equivalent diagram, and here let's take the equivalent resistance is the RS. Here also current I, and here also current I. So here students, remember that the calculation of the equivalent means a single resistor which can replace these three resistors. Okay, so here you can see very well as potential gets distributed. So what will happen that here, if in case here potential is V. So remember that here students, here what will be there? This V will be equal to V1 plus V2 plus V3. Okay, this thing you have to remember that in a series combination, V1, V2, V3, because resistors are different. If in case resistors are same, resistances are same, then this value can be same also. That's not a big deal. Okay, after that what will happen that here, kindly put the value. What is the V? From here we'll write the V equal to I into RS from the Ohm's law. Okay, so we can write here, see, IRS is equal to, what is V1? Current is I, resistance is R1, that means we can write here IR1. Similarly, what is the V2? Current is I, resistance is R2, IR2. Similarly, current is I, resistance is R3, IR3. Okay, so from here what we can write here? We can write here this IRS is equal to I is common. We can write here R1 plus R2 plus R3. Then what will happen, students? Both the sides, this I and I will cancel out. That means we can write here this RS equal to R1 plus R2 plus R3 for three resistors. If in case this is the two resistances, we can write RS equal to R1 plus R2. If in case four resistors, we can write RS equal to R1 plus R2 plus R3 plus R4. Like this will go ahead. Okay. Next one, students, under the important points. Let's see here what is the important points are there. See, first one, in series combination, potential difference and power or energy distributes in the direct ratio of the resistances. Okay, so first one we'll see here the potential difference. How can we tell this here? We know very well as V equal to IR, correct? And I have told you in series combination what is constant? Current is constant. Okay, that means we can write here V directly proportional to R. What is this? V directly proportional to R. So if in case, if I write for the three resistors, I can write here V1 is to V2 is to V3. How much coming is there, students? IR1 is to IR2, and here how much, students? Here IR3. Is it? Now I all will cancel out. That means we can write here R1 is to R2 is to R3. Correct? That means we can tell very well potential difference is the direct ratio of the resistances. This concept only we will use in a voltage divider theorem. Next one. Similarly, students, if I write here the second one, like power. So remember that here in series combination we will use the formula of the power as P equal to I square R. This is a very easy. Okay, because current is the same, so we can tell P directly proportional to R. So students, as the P directly proportional to R, in the same way we can write here. Kindly see, students, P1 is to P2 is to P3 will go here what? I square R1 is to I square R2 is to I square R3. That means we can write here, see here, R1 is to R2 is to R3. Okay, students. So this thing and here this thing we have to remember that. Even you know energy equal to power into time. So in the same time, energy ratio will be also same only. Okay, I hope so this is very clear. Now students, we are going to see here the voltage divider theorem. Now, based upon the previous concept. So under the voltage divider theorem, first I have taken here, see the R1 students, here R2 and here R3. Voltage is V as I have told you. And here how much is there? This is the V1, this is the V2, and here what is this students here? This is the V3. And here the current is I. So what we can write here? Directly remember that here. If I write here, if I want to write here the V1 I can write here R1 by R1 plus R2 plus R3 into I. Not I actually, V. Okay, this is the V. Similarly, if we write for the V2, what will the V2? We can write here, see, R2 by R1 plus R2 plus R3 into V. I hope so this you are understanding very well. Okay, now let's take, if I write here for the third one, V3. Even I can go with the more basics here. V3 I can write here, see, IR3, correct now? Because current is I, resistance R3, so IR3. And what is the I? I is given by V by total resistance R1 plus R2 plus R3 and into R3. See, you can see very well no? How we have done this. Similarly students, if in case the two resistors are there, let's take here R1, R2. This is a very common, okay? And here V, and we can tell very well this is the V1 and the students say this is the V2. Is it? Then what we can tell? Can you see here? Again, if I write here, see, this is for the first one, and if I am writing for the second one, what will happen that here? See here, students, first one V1 is equal to, same way, voltage divider theorem, R1 by R1 plus R2 into V. Is it? Similarly, students, next one, V2 is given by, see here, R2 by R1 plus R2 into V. Can you see very well how we have done this, students? I hope so. All these things you are understanding very easily. Is it? Now let's see, students. Now, under the third one, let's see here. Now, let's see here, students. If n resistors of equal resistance R are connected in series with supply voltage V, then their equivalent resistance, first equivalent resistance, and potential difference across each resistor is given by. Okay. So first let me talk about the equivalent resistance. So here this is R connected with the battery. So you know what will happen that here, if I calculate here the equivalent between point A and B, now because between point A and B battery is connected. So what will happen that here, the first one is, students, this R equivalent or RS is given by what is this, R plus R, or we can write here the 2R. For two resistors, they are connected in series. What is the equivalent? 2R. Okay. Similarly, if I talk about here the potential differences. So you know very well, as the resistors are same, resistances are same. So let's take here this is the V dash, and here also I can write here the V dash. So you know very well, as we know very well, this V equal to V1 plus V2, is it? But here resistors are same, so we can write here V dash plus V dash. That means what we can write here? V dash is equal to V by 2. That means voltage will divide equally. Similarly, students, if I write for the, this is the first one, no? If I write for the N, how many is there? N resistors of equal resistances. Then you know what will happen right here? We can write here R is equal to NR. 2 resistors means 2R, 3 resistors means 3R. Similarly, for the N resistors, NR. Okay. So this is the A. If I write for the voltage, what will be the voltage here? Can you see here? This V dash is given by V by N. What is V dash? V dash is given by V by N. V dash is given by how much, students here? This is given by V by N. Is it? I hope so. This is the very clear. Okay. Now, students, after the series combination, we are going to see here the parallel combination. See here? Parallel combination. So see, in parallel combination, potential difference across each resistor remains the same, okay, but current gets distributed as shown in a circuit diagram. Okay, in a series combination, what was same? Current was same, but here what will be same? The potential difference across each resistors will be same. Okay, so can you see here? This is the voltage V, here resistance R1, this resistance R2, this resistance R3, and here the current is coming I. Then you know what will happen that here? Let's take, in this current is going I1, in this current is going I2, and in this current is going I3. Is it? And let's take, this is the equivalent diagram. equivalent resistance Rp, that means a single resistance which can replace this 3 resistances. Okay, and again same thing, this is I, and here potential is V. Okay, so students, here what we can write here we can write here, see, current I is equal to I1 plus I2 plus I3. Okay, for the series combinations it was V equal to V1 plus V2 plus V3, but for the parallel combination, current one we have to write here. Okay, now from here, what is the value of the current? I equal to, students, I equal to V by Rp. Okay, and what is the I1? We can see from here, see, here the potential is V, across the resistance R1 V, here also V, here also V. So we can write here V by R1 plus V by R2 plus V by R3. Then you can see very well, both the sides, what will happen? The V will cancel out. I can take V common, so we can write here, see, 1 by R1 plus 1 by R2. I am writing each and every step for you, 1 by R3. And what will happen right here? Both the sides, this V and this V cancel, is it? So students, we can write here, see, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula. And remember that here, whenever you are using this formula, please make sure that left side 1 by Rp is there. Number of times we do the mistake. Okay, so 1 by Rp is there. Similarly, if we write for the 2 resistors, that is also very handy, for 2 resistors. For 2 resistors. For 2 resistors. So what will happen that here, in this situation, it is given by 1 by Rp is equal to 1 by R1 plus 1 by R2. That means I can write here Rp equal to, after taking LCM and all that, it will come here R1 R2 by R1 plus R2. Okay, can you see very well? How much is coming? Rp equal to R1 R2 by R1 plus R2. I hope so, students, this thing is the very clear to you. Is it? Great. Now, next one we can see again some important terms are there. Okay, let's see here, students, see. In parallel combination, current and energy, or even we can tell power, like we have done for the series combination here, current and energy or power distributes in the inverse ratio of the resistances. Okay, so first one we are going to move for the current. So we know very well I equal to V by R, correct? And what is constant? V is constant. That means we can write here I is inversely proportional to R, or we can tell directly proportional to 1 by R. Is it? This is there. So if I write here for the 3 resistors, so we can write here I1 is to I2 is to I3. What will be there? See here, V by R1 is to V by R2 is to V by R3. And what will happen at here? This V will all will cancel out. So we can write here, students, here 1 by R1 is to 1 by R2 is to 1 by R3. Is it for the 3 resistors in series? Similarly, if in case I write for the 2 resistors in series, so see here I1 is to I2 for 2 resistors in not series, actually parallel. Okay, so what will be happen here? 1 by R1 is to 1 by R2. Parallel combination we are seeing. Important points for parallel combination. Okay, so this is for the current. Similarly, students, if we write for the power, so which formula we have to use here? V is constant, that means we have to write here P equal to V square by R, or we can tell here P is inversely proportional to R. Okay, so here if in case I write here for the 3 resistors in parallel, P1 is to P2 is to P3, what will come here? See, 1 by R1 is to 1 by R2 is to 1 by R3. Okay, and if in case you want to simplify this, just multiply here with R1, R2, R3. If you want to simplify further, so when you will multiply here, what will come here? R2, R3 is to, here what will come? R1, R3 is to, here what will come? R1, R2. Okay, I hope so you have understood this very well for the power 3. Okay, similarly you can write for the 2 also, not a big deal. Now students, next one we are going to see very important, even in our next chapter, moving charges and magnetism chapter also we will use this here, please. So here what is there here, see, this is R1, this is R2, this is R3 connected in parallel across point AB. Current is going I. So here how much current here is, students? I1, here current I2, and here current how much? I3. Okay, I3 is there. Now what will happen here, students, if I will see for the first one? Okay, so if I write here the I1, you know very well, I is inversely proportional to R. So we can write here this I1 is given by, for 1 by R1, and here 1 by R1 plus 1 by R2 plus 1 by R3 into I. Okay, and if in case you will simplify this by taking LCM and all that, so it will come here, see, R2 R3 by R1 R2 plus R2 R3 plus R3 R1, okay, and here into I. But this is the best way to remember that here, okay. After the students, if we'll write for the second one, let's take it for example B. What will be the I2 in the same way? Students, can you see here? I2 will be what you see? 1 by R2 by 1 by R1 plus 1 by R2 plus 1 by R3 into I. Is it? Even if we will simplify also, what this will become here? I can see very well here, no? So I2 means it will become here, see here, R1 R3 by R1 R2 plus R2 R3 plus R3 R1. Okay, and here into I. Is it? Very great, very great, very great. Is it? Similarly, if we write for the third one, I hope so you have understood very well here, I3. So what this will become here, see, 1 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3 into I. And here mistakes happens, so I am writing here, see, here I3 means here it will become here R1 R2 by, see here, R1 R2 same story plus R2 R3 plus R3 R1, okay, and here it will become here into I. Is it? I hope so you have understood this very well. Okay, great. Now students, after that we will go for the two registers. That is the very common in exams and all that. Okay, so see here, what will happen that here, see, here I have taken R1, here I have taken R2, here this is point A, and let's take this is point B. How much current is going here? I1, and here current is going I2. Okay, so what will happen that here, for the second one if I write is there, see here please, A. What is the I1? I1 is given by 1 by R1 by 1 by R1 plus 1 by R2 into I. Very important, that's what I am doing is there. Okay, so when we will simplify this students, it will come here what? R2 by R1 plus R2 into I. Okay, so see, I1 equal to what? R2 by R1 plus R2 into I. Okay, students. Similarly, if we write for the second one, B, I2. What will be the I2? See here, I can write here, see, 1 by R2 by 1 by R1 plus 1 by R2 into I. Okay, and when you will simplify further, you can write here R1 by R1 plus R2 into I. Is it? I hope so. Let me change here the color. See, this is the I. This is the I, and here like this is there. Okay, so you can write here I1 means that side R2 by R1 plus R2. I2 means that side R1 by R1 plus R2 into I. Na? That's why current divider theorem, remember that very well. Students, here please, again I will tell you one more thing. Okay, so see, in a voltage divider theorem, what was there? If you will see V1 this side R1, V2 this side R2. Is it? Can you see very well? But if in case you will go for the current divider theorem, then what will be there? Here I1 means R2, here I2 means R1. I hope so you have understood very well what I am coming to tell you. Okay, great. Now third one, students, what is there? Can you see here? See, if n resistors of equal resistance capital R are connected in parallel with supply voltage V, then their equivalent resistance. Now first let's see the equivalent resistance. So here what is this? This is the R, this is the R, and here this is A, this is B. So what will happen here, students? Can you see here very well? The first thing I am going to tell you. Now, so here equivalent resistance will be what is this here? 1 by Rp is equal to 1 by R plus 1 by R. Is it? That means we can write here, students, this will become here how much here? 2 by R. Okay. So from here we can write here Rp is equal to R by 2. Two resistors in parallel, how much? R by 2. Is it? Similarly, if I write here the current. Okay, so see here, let's take the current is I. Both the sides resistances are same. That means let's take here, this is I dash and this is I dash. So if in case I apply the KCL, okay, so we can write here, students, see, I equal to I dash plus I dash. Then what will happen here, students? You can write here I dash is equal to I by 2. So this is for the two resistors connected in parallel. Okay, but if in case, students, we'll do for the n resistors. How many resistors? N resistors in parallel. That means what will happen that here, remember that here this Rp will come here R by N. Okay, 3 resistors in parallel means R by 3. 4 resistances are in parallel means R by 4. Okay, in the same way. And what will the B? The current is given by this I dash. It will become here I by N. Okay, students. So I hope so this is a very clear to you how to deal with the resistors are connected in a parallel but equal values. Okay, great. Now students, after that we are going to see here some basic questions. basic questions on register combination. So see here please, first one, here I have taken A and B, and let's take this resistance is R, this resistance R, this resistance is R. Can you tell me very well what is the equivalent is there? See, directly we can tell here. Okay, see here, RAB is R and R in series. How we can tell R and R in series? Let's take for example, if in case any current I1 is going, so here also I1, here also I1, is it? That means these two resistances are in series. So R and R in series 2R, then this 2R and this R in a parallel, then I can use the formula R1 R2 by R1 plus R2. Okay students, so here this 2R into R by 2R plus R. So this will become here what? It will become here 2R by 3. Okay, we are seeing just basic thing. Okay, next one, similarly if we see the second one. Second one, what is there, students? See, this is R, and this is R. So tell me, answer same or different? Answer will be same only. Not design does not matter, connection matter. Here also 2R by 3. Here also it will be how much here? 2R by 3. Okay. So see here, this RAB will be how much here? 2R by 3. Maybe there upward it is looking like a rectangle. Here it is looking like a triangle. But the answer is going to be same only. Okay. Because in electricity, what matters? Connections matters. It does not matter looking like a triangle na, a square na, any other shape na. What matters? Connections matters. Okay. Similarly, students, if we'll go for the third one, what will be there in this situation? What is the answer? See. So this kind of question is also very common. This kind of question we have to start from here, this side. Okay. Because here, this one here, this 3 ohm and 3 ohm connected in a series. Why? Because see, if in case battery will be connected here across point A and B. So if in case here current is going, for example, I1. So here also how much current is there? I1 current is there. Is it? That means what we can tell? Listen very properly. See, this 3 ohm and this 3 ohm connected in series 6 ohm. Okay. This 6 ohm in a parallel. That means 3. Again this 3 and this 3 in a series 6. This 6 and this 6 in a parallel 3. This 3 and this 3 in a 6. And this 6 and this 6 overall in a parallel. That means how much? 6 by 2, 3. Okay. So what will happen, that students, here? This RAB will come here 3 ohm. I hope so. This one you have understood very well. You just start with here, apply the symmetry. Answer will come very easily. Okay. Now after that, what will happen, that here? They will tell in a question like one wire is there. For example, resistance 10 ohm, and we are going to calculate the equivalent across the diametric ends, diagonal opposite ends. Okay. So resistance of the wire, how much time telling that? 10 ohm. Okay. So see here, this is the A, this is B. So this is the half of the circle. So if the total is 10 ohm, that means this side 5 ohm, and this side also how much here? 5 ohm. Here the wire is there, and we can tell very well here what we can tell, the resistance is distributed all around the wire. Okay. Here also this resistance is distributed all around the wire. Now here we can tell the resistance is the distributed. Here resistance is distributed. Here resistance is the lumped and distributed voltage there. Okay. So what we can tell here, this 5 ohm connected across AB, this 5 ohm is also connected across AB. That means here students, we can tell this 5 ohm and 5 ohm connected in a parallel, R by 2, or we can tell 5 by 2. Answer how much here students here? 2.5 ohm. Can you see very well how we have done in a very beautiful way? Is it? Great. Now students, see, this question is there. Now, so see here. This question number 5, very important. Here in this question, we are going to see the equivalent between A and B. What we are going to see, students, here we are going to see equivalent between A and B. So remember that here in this kind of question, if in case you are connecting the battery here across AB, then you know what will be there, students. Here you can see very well, if in case any current is flowing here, let's take for example here current, for example I1. Any current will flow this side? No, because this is a which circuit? Open circuit. Is it? Similarly, any current this side? No, because anyhow open circuit is there, OC. So if in case I1 is coming here, here also how much is there, students? I1. And here also, let's take one resistor was there. And here also how much here? I1. Okay. So students, you can see very well, this R, and this R connected in a series. Okay. So if in case I draw here the one equivalent diagram here. Okay. So see, this is the equivalent diagram here, students, here. This is A, this is B, R. And here how much R? And see, this R connected in a series. That means how much here is, students, here? This is the 3R. Okay. Then after that we can tell very well, see, this 3R and R in a parallel. So 3R into R by 3R plus R. It will become 3R plus 4. So this R, 3R by 4 plus R. So we can write here, see, R plus, here how much here? Equivalent, this equivalent here, students. How much here? R1, R2 by R1 plus R2. So 3R by 4 and plus R. So we can write here, see, 2R plus 3R by 4 And when you will simplify this, students, it will come here 11R by 4. Okay, so remember that here across point AB, when we are seeing, these two resistors will cancel out because their current will not flow, and when you will apply little bit current concept and all that, you will get the answer. Okay, and here students, see here RAB, we have got here 11R by 4, is it? Now in last question, what is there students? Very, very important. They used to ask the resistance between point R, AD, not CD. We can write here RAD. This is the RAD. So here what will happen, that is students, if you want to get the resistance across point RAD, see here, this one and this one, RAD I will take here, and here I will apply here one battery. One battery is there. So you know very well here, to get the equivalent across point AD, what will be there? Which resistors? They will not carry any current. You can see very well here, no current. Is it? Because here open circuit. And here also what is this? No current. That is also open circuit thing is there. Okay. After that, apply little bit basic. So what will happen that here? Let's take here, for example, here current is going I. So here what current will go here? Students see I1. Here also, this side no current. That means in this also how much here? I1. Is it? Now let's take for example, this side current is going I2. Okay. So here also how much current will go here? I2. Remember that here, because this side no current. Again I am telling that if in case current is coming I, here I1, here also I1. This side no current. Similarly, from here current is starting I2, this side also I2, because this side no current. Okay. So you can see very well which resistors are connected in series. This R and this R connected in series. Similarly, this R and this R connected in a series. Okay. So if in case I draw here the equivalent. So what we can write here, see, this is the R, this is the point A, no? This R. This R and this R in series, how much? 2R. Similarly, this R and this R in series, how much? 2R. Okay. Even I can write here some names also here, please. For example, this is the M and this is the N. Okay. So this is the M. And here what is this? This is the N. And here also students, this resistance R is there and this is the point B. Now can you tell very well students, what is the answer is there? See, this 2R and this 2R in parallel, that means 2R by 2. So 2 cancel R. This R, this R, this R in series, that means equivalent between point AD, how much is there? 3R, okay? Because this one is having the resistance, how much here? This one is having the resistance R, is it? Can you see very well? Is it? This kind of questions are very common, students. So I hope so this video you have understood very well. Keep studying, keep growing.